Okay, hi everyone. Let's take our moles and let's apply them. I want to start with that CH4 again. I want to start right there. And I want to picture that this methane, this formula that we're looking at, it is an entire story. There is so much that we can write out just by seeing that formula, CH4. I mean, let's think about it. We've already learned in Unit 2 that this is a covalent bond. In fact, we can draw the structure. This is that whole molecule. Boy, that's some bad drawing. Sorry, y'all. And that whole molecule, we can even give it shape. Look at that. It is tetrahedral. We can draw it. It's sp3 tetrahedral. We know what that whole molecule looks like, all just from that formula. What we're doing in this section is the exact same thing, only we're adding numbers. So whenever you see a formula, you have to picture it's almost like an entire essay. It's like a whole story. So what is this methane teaching us? Well, let's write out each time we see a formula. If you're new to moles, you're going to want to write this out every time you see a formula. If your moles are fresh, you just did it last semester, you don't need to. This is the last video that we'll do this. Everything after this, we're just going to use these numbers, but let's take our time and just write out the full essay that comes with that formula. So if we have 1 mole of CH4, we're going to picture that that is the whole compound. Literally, we just drew it in our last unit. That is stuck together. That is a molecule. So how many of those molecules do we have? Well, in 1 mole, we're going to have Avogadro's number. This time our entity, our elemental entity, or our particle is going to be a molecule. It is that whole thing together. And then how much is that going to weigh? Well, this one we have to calculate a little bit. So let's carve some space here. How do we figure that part out? Well, we've got our whole molecule here. All right, what makes up that molecule? Well, for each one of those molecules, don't you have 1 carbon and 4 hydrogens? So we've literally got 1 mole of carbon atoms in that molecule. And how many is that? That is 6.022 times 10 to the 23rd. And that is this time atoms of chlorine. And then this one's easy. We just did this one on the last video. How much does this weigh? This is our atomic weight, 12.011 grams. Okay, I love it. But what else is in our molecule? It's not just carbon, it is also hydrogen. So if we picture a mole of hydrogen atoms, okay, but we don't have just 1 mole, do we? We have 4 of those hydrogens. Look, in our formula, we've got 1 carbon, 4 hydrogens. So let's do Avogadro's number first. That means in every mole, we have Avogadro's number of those atoms, except we don't have just 1, we have 4 times, okay? And then let's look at how much it weighs. So let's go ahead and let's add up that weight. Okay, well, our atomic weight for hydrogen is that. That's your atomic weight for hydrogen. And this time we have 4 of those also. So what does that mean? That means, okay, if we want to add up the total in that molecule, that means that we have 1 carbon and 4 hydrogens. Okay. In fact, let's just add, I want to include that down here. So that's 4 point. So what is that total for methane then? Grab your calculator, let's do it. Okay, that equals 16.363 grams. That is our molecular weight. Okay, now I want to add some vocab here. I want to add another concept. That concept is that for every one carbon, you have 4 hydrogens. This is something we're going to call our mole ratio. We're going to use that in a whole lot of problems. So let's double check that this video is working, and then we're going to add to that.